Hey everyone, welcome to another episode of Let's Lead. Before we start today's episode, I would like to introduce Mr. Bones. He is an assistant to Bob, and whenever Bob is busy, he'll be the one to take care of giving us tips and tricks. So moving forward with today's problem, today we will be talking about the problem of adding two numbers. The problem is fairly simple. We have two non-empty linked lists and they are in reverse order, and each of the nodes contain a single digit. Okay, we need to add them and return the sum as a linked list, as simple as that. Now what needs to be done is, let's say for example we have the linked list 1, that is 2, okay, 4 and 3, okay, and we have linked list 2, 5, 6 and 4. They are in reverse order. Let's talk about the elementary sum. How do we do it? Let's say we have two numbers. For example, let's take this number only. Since it is in reverse order, it would be 342 and this would be 465. Now when we start summing a number, we sum it from ones digit, then the tens, and then the 100. So 2 plus 5 will be 7, 6 plus 4 will be 10, and 1 will be carry forwarded, okay, and 4 plus 3 plus 1 would be 8. This is how we generally sum up the numbers. Okay, a couple of edge cases to take care. First, let's say I have the same linked list, but the number 2, 4, 3, okay, and before this I also have 7, for example, okay, and similarly I have 5, 6, 4, the same. So this becomes 3, 4, 2, 7 plus 465, okay. Now when I start summing up, 7 plus 5 will be 12, carry forwarded 1, okay, then it will be 6, 7, 8 and 9. This will be 8. Now if you think in perspective of a linked list, my first linked list has a number, but my second linked list is blank now because I have exhausted all the nodes of linked list. In that case, what we can do is we can replace an empty node with 0, and then 3 plus 0 would be 3. So this is how a sum will be done. Now another edge case to take care here is, let's say here we have 7, okay, in the same linked list we have 7. What now? Let's say if I put it and try to add it, 3, 4, 2, 7, and next will be 7, 4, 6, 5. If I start adding, this will be 12, carry 1, 6, 7, 8 and 9, 8, 7, 8, 9, 10. And actually what happens is, in general terms we write it directly here, but actually what happens is 1 is carry forwarded, okay, and since 0 and 0 is there, we sum it up and 1 is put down like this. So this is an edge case. In case we need to make sure that in case in the end we have a carry forward and both the linked lists are exhausted, we need to add the carry with the 0 values of linked list 1 and linked list 2, okay. So this is how we will do. Let's go ahead and take a look at the implementation. Talking about the implementation, I'll use the lead code editor itself because it has the list node class implemented, so I can directly use it. Now I will create a dummy node. The L1 and L2 are the two linked list, okay, so I'll create a dummy node. It's kind of an empty node just to avoid any edge cases. Dummy node will be list node. I call the list node class, okay, and point the current pointer to the dummy node, okay. Now I will create a carry variable to store the carry values, okay. Now I need to run a loop until unless there are any elements left in either of the linked list, okay. So L1 or L2, okay, and after this what I can do is value 1 would be L1 dot val if L1 has any value, else it should be 0. In a similar manner, I'll copy paste this directly and change a few things. The value 2 would be v2, L2 dot val if L2 has any value, else 0. Okay, going forward, for example, a new digit comes in. What we have to do is val will contain v1 plus v2 plus the carry variable. Okay, so v1 plus v2 plus the carry variable. Okay, now I need to update the carry variable for the next value. So that would be val divided by 10. Okay, and in a similar manner, I need to store only the ones digit of a number. Okay, so that would be val percentile or modulus 10. So what is happening here is, let's say my sum comes out to be, for example, 34. So in this part, I am doing val divided by 10. This will give me 3, so carry will be 3, and here the val variable will contain val modulus 10, that is nothing but 4. Okay, so val would be 4. Now once I have these two things, I will place it into the next node of my list node. Okay, so it will be list node val. Okay, and after this we need to update the pointers. Pointers will be dot next. Similarly, L1 would be L1 dot next if L1, else none. Okay, and in a similar fashion, L2 pointer will also be updated if L2, else none, and then return dummy dot next. Okay, all the variables after dummy would be returned. Now we think that it is done, but it's not done actually. As we talked about the edge case, where in the last digit, if there are two values which sum up greater than 10 or greater than 9, in that case my carry will contain my value, but since the L1 it's L1 and L2 are exhausted, that carry will never be added to my final answer, and I'll get a wrong answer. So to counter that case, we also need to make sure that carry has some value. Okay, so if carry will have some value and both L1 and L2 are exhausted, V1 will be 0, V2 will be 0, but the carry will be added to value, and that would be added to the next node of the my linked list, and that will be returned. So this is the implementation. Let's go ahead and run this. It's done, and this is how this problem could be solved. Thank you so much, and I'll be back with another episode.